Lesson 1.3, Properties of Numbers. Expressions that represent the same number are called equivalent expressions or equal expressions. For example, 4x plus 8x is equal to 12x. So this expression, 4x plus 8x, is equivalent to this expression, 12x. Today we're going to go through many properties. Most of these properties you already know, but perhaps you don't know their names. So we are going to learn their names, we're going to learn what they mean, and we're going to go through examples of each property. Okay, so first we're going to look at properties of equality. Properties are rules or laws in math. Okay, properties of equality. The first property that we'll look at is the reflexive property. Reflexive property says this. It says that any quantity is equal to itself. For example, A is equal to A. 5 is equal to 5. 4 plus 7 is equal to 4 plus 7. Of course, you already know that, but you didn't know it was a property. You probably didn't know its name. Reflexive property. I like to think of reflexive as reflective. Same thing on one side as on the other. A equals A, 5 equals 5, 4 plus 7 equals 4 plus 7. Okay, the next property is the symmetric property. Symmetric property. Here's what it says. If one quantity equals a second quantity, then the second quantity equals the first. So it says this, if A equals B, then B equals A. If A equals B, then B equals A. And if 8 equals 2 plus 6, then 2 plus 6 equals 8. That's called the symmetric property. If one quantity equals a second quantity, then the second quantity is equal to the first. All right. The next property of equality is transitive property. Transitive property. Here's the definition. If one quantity equals a second quantity, and the second quantity equals the third quantity, then the first quantity equals the third quantity. Pause the video, take a moment, and copy that down. So let me give you an algebraic example. If A equals B and B equals C, then A is equal to C. As far as a numerical example, if 6 plus 9 is equal to 3 plus 12, and 3 plus 12 is equal to 15, then we know that 6 plus 9 is equal to 15. So take a moment, think about that, take a good look at it. Make sure you have it in your notes before you move on. So you might want to pause the video. Okay, let's continue. Substitution property. Substitution property is the last of the properties of equality that we'll look at today. And here's what it says. It says that a quantity may be substituted for its equal in any expression. A quantity may be substituted for its equal in any expression. So if A is equal to B, then A may be replaced with B in any expression. In the same way, if n is equal to 11, then 4 times n is equal to 4 times 11. We can substitute 11 for n in the expression. Okay, so that takes care of our properties of equality. Now let's look at addition properties. Addition properties. The first one is additive identity. Additive identity. It says that for any number, such as a, the sum of a and 0 is a. In other words, adding 0 to any number doesn't change its identity. That's how I like to think about it, so I remember its name. Additive identity. If I add 0 to anything at all, it won't change that quantity, that number. So, as far as an example goes, a plus 0 equals 0 plus a, which is equal to a. Because adding 0 to anything won't change its identity. Okay? And a numerical example, 2 plus 0 is the same as 0 plus 2, which is 2. Adding 0 to anything will not change its identity. Additive identity property. Alright, so the next one, addition property, is the additive inverse. Additive inverse. And here's what it says. A number and its opposite are additive inverses of each other. That means that their sum will be 0. A number and its opposite are additive inverses of each other, and their sum is equal to 0. So if we have a plus negative a, it equals 0. 3 plus negative 3 is equal to 0. Whenever you add opposites, your sum is 0. All right, let's move on to multiplication properties. The first one is the multiplicative identity property. Multiplicative identity. Multiplicative identity, and here's what it says. It says that for any number a, the product of a and 1 is a. When you multiply any quantity by 1, that quantity does not change its identity. It remains the same. So multiplicative identity says that the product of 1 and anything will be that quantity. So as far as an algebraic example goes, a times 1 equals a. 1 times a equals a. Any value times 1 does not change that value. As far as a numerical example, 14 times 1 equals 14, and 1 times 14 equals 14. Again, multiplying any number by 1, that number will keep its identity. Okay, let's continue. As far as multiplication properties, we have also the multiplicative property of 0. Multiplicative property of 0. It says this, that for any number a, the product of a and 0 is equal to 0. So any number times 0 is going to be 0. Now I know you know that. It's just that I'm giving you the name of a law or a property in algebra. And we will be needing to know these names because we will be using them in this lesson. Multiplicative property of 0 says this. For any number a, the product of a and 0 is 0. Let's look at some examples. A times 0 is 0, and 0 times a is 0. A numerical example, 9 times 0 is 0. 0 times 9 is 0. whatever quantity you multiply by 0, the product is going to be 0. That's the multiplicative property of 0. And then the last multiplication property is the multiplicative inverse property. Multiplicative inverse property. It says for every number a over b, where a or b are, and I'm sorry, this is not equal to 0. There's exactly one number, b over a, such that the product of a over b and b over a is 1. Multiplicative inverses, you also can call those reciprocals. So the reciprocal of a over b is b over a. So when you multiply a quantity by its reciprocal, also called its multiplicative inverse, or its opposite, the product equals 1. So let's look at my examples. A over b times b over a equals 1. Conversely, b over a times a over b is equal to 1. If we look at a numerical example, 4 over 5 times 5 over 4 is equal to 1. 4 over 5 times 5 over 4 is equal to 1. So every fraction has a multiplicative inverse. Every fraction has a reciprocal. And when you multiply reciprocals, your product is always equal to 1. That is the multiplicative inverse property. Okay. Some more properties. This time we're going to look at general properties that have to do with different operations. Commutative property is a property that relates to addition and multiplication only. Addition and multiplication only. And here's what commutative property says. Commutative property says this: the order in which you add or multiply numbers does not change their sum or product. So commutative property has to do with the order of the terms that you're adding or multiplying. It has to do with the order of the terms. Okay? Commutative property says you can change the order in which you add or multiply numbers. So look at my example. A plus B is the same as B plus A. And A times B is the same as B times A. The order of those numbers does not change the sum or the product. But please note, that's not true for subtraction or division. It only works for addition and multiplication. Okay, a numerical example, 4 plus 5 is equal to 5 plus 4. And 4 times 5 is equal to 5 times 4. Commutative property, again, has to do with the order of the terms. Okay, let's go on. Associative property. Associative property says the following: the way that you group 3 or more numbers when adding or multiplying does not change their sum or product. Associative property has to do with grouping. It has to do with grouping, where the parentheses group 2 or more terms. Notice associative property also works only for addition and multiplication. It does not apply to subtraction and division. Only addition and multiplication. So let's look at our example. In parentheses, a plus b, and then plus c is the same as a plus, in parentheses, b plus c. Notice with me the order of the terms did not change. A, B, C, A, B, C. The only thing that changed here is which terms are in the parentheses. That's associative property. Which terms are being grouped. The same works for multiplication. A times B times C with a B in parentheses is the same as A times B times C with BC in parentheses. Okay, as far as a numerical example goes, 3 plus 5 in parentheses plus 7 is the same as 3 plus 5 plus 7 in parentheses. And here in multiplication, 2 times 6 times 9 in parentheses is the same as 2 times 6 times 9 in parentheses. Okay, so tomorrow we're going to practice a skill that I'm going to just introduce to you now. I want you to work with me on a few problems where we are going to be asked to follow the following directions. It's going to say evaluate each expression and name the property used in each step. So this is kind of a lengthy exercise, but what I want you to look at and to understand is that what we'll be doing is using these properties and explaining how they apply to solving or evaluating a problem. So write down number 1, 2 times 3 plus 4 times 2 minus 8, and 4 times 2 minus 8 is within parentheses. Okay? So the first step that we're going to take here is going to be to evaluate 4 times 2, and 4 times 2 is 8, and so we'll bring it down this way. 2 times 3 plus 8 minus 8. And what property did we use in this step? Well, we used substitution. Because 4 times 2 is equal to 8, I can substitute 8 for 4 times 2. All right, so the next step we're going to do is 8 minus 8, or 8 plus negative 8. Okay, so we have 2 times 3, and then 8 minus 8, or 8 plus negative 8 is 0, and this is the additive inverse property. Okay. All right, so when we're done there, the next thing we'll do is multiply. So 2 times 3 is 6, and bring down the plus 0. And this property is substitution. Because I know that 2 times 3 is equal to 6, I can substitute 6 for 2 times 3. And then 6 plus 0 is 6. Well, that's additive identity, because we learned that anything plus 0 is itself. So we are going to be actually solving problems, evaluating expressions, and explaining the properties that we used for each step. All right, number 2, you're going to try on your own. Pause the video now, do the best that you can, and then come back and check how I did it and how I explained each step. Pause the video, please. Okay, I know you probably got the answer 1, but my concern is, did you know how to explain each step and name a property? So I'll go through this step by step with you. My first step here is to take 15 divided by 3 and evaluate that. So my answer is 5, and what I use there is substitution property. The next step is to subtract 5 minus 5 equals 0, and 5 and negative 5 combined is additive inverse because I'm adding opposites. All right, the next step that I have to do is 7 times 1 over 7. Well, 7 over 1 and 1 over 7 are reciprocals or multiplicative inverses. So I know that when I multiply multiplicative inverses, my product is always 1. So I explain that step using multiplicative inverse property. The next step is 6 times 0, and I know that anything times 0 is 0, so I'm going to use multiplicative property of 0. And 1 plus 0 is 1, and that's additive identity. Anything plus 0 is itself. The temptation here is to use substitution as an explanation for everything, but that wouldn't be correct. If you have a property that is familiar, that is being used, that we've gone over, that's the property you must use and not substitution. Okay? All right, let's continue. Let's look at number 3. Write it down, please. 5 times 7 times 4 times 2. Well, I look at this problem and I'd like to do as much of it as possible using mental math. So the properties that I've given you really facilitate mental math quite a bit, especially commutative property and associative property. Commutative property, remember, has to do with the order in which we add or multiply terms. In this case, the easiest thing for me to do is to multiply first 5 and the 2. Because that product will be 10, and multiplying by 10 is really simple. So I can use commutative property to change the order in which I multiply these. So I can do 5 times 2 times 7 times 4. And I can explain that step because I used commutative property of multiplication. So we're going to write it down, of multiplication or of addition. Commutative property of multiplication. The next thing that would be nice is if I could insert some grouping symbols here. Okay, so I would do 5 times 2 in a grouping symbol times 7 times 4 in a grouping symbol. And that property that allows me to introduce grouping symbols or change grouping symbols is associative property, also of multiplication. And now this facilitates mental math because 5 times 2 is 10 times 7 times 4 is 28, and that's substitution property. And then 10 times 28, I don't need a calculator, I don't need a piece of paper and a pencil. I know how to multiply that using mental math is 280, and that is also substitution. Okay. Number 4, copy it down and I'll work it out with you. Number 4, 5 over 3 times 25 times 3 times 2. So when I look at 5 over 3, I would love to get rid of that fraction. So I realize that the ideal order for this would be as follows: 5 over 3 times 3, or 3 over 1, times 25 times 2. See, multiplying 5 over 3 by 3 is going to get rid of the fraction. I'll have a whole number. Which property lets me change the order that way? It's called commutative property of multiplication. All right, so the next thing I would like is I would like to be able to group the 5/3 times 3. And then I would also like to be able to group the 25 times 2. So we know that to introduce parentheses or to change parentheses, we use associative property, in this case of multiplication. All right, so let's continue. 5/3 times 3, or 3 over 1, we know is 5. Times 25 times 2, we know is 50. And all we did here was substitute. And then 5 times 50 is 250. And that is also using substitution. Okay, just a couple of problems for you to do independently. Try to do these. We will go over them tomorrow step by step. But I want you to try number 2 and number 4. And here I'd like you to try number 6 and number 15. Okay, be sure you jot down any questions. I know that this was a very long note-taking lesson video, but it's important, and I'm glad we took this time at home rather than in the classroom. In the classroom, we will practice writing down and evaluating expressions by justifying each and every step, naming the properties until you know them by heart. So we will be practicing more tomorrow. Make sure that you're ready for tomorrow's classwork. God bless you. Have a great night.